Good day. Let me introduce our research. Distribution of radionuclides in modern sediments of the rivers flowing into the Dnieper-Bug Estuary. Aquatic ecosystems play an important role in the migration of both natural and artificial radionuclides, as well as in their redistribution. Sediments of reservoirs and watercourses, to a large extent, fulfill the deposit mission of substances entering the water from catchment areas during coastal erosion and runoff from adjacent areas. Thus, composition of sediments, including radionuclides, reflect the ecological state of rivers and their catchment areas. Man-made radionuclides, such as radioactive and radiostrontium, spread mainly by airway, to a lesser extent waterways. The relevance of the presented studies is determined by the decision to build the E40 channel. The E40 waterway is a transnational initiative aiming to link the Baltic and Black Seas by an approximately 2,000-kilometer long navigable connection running from Gdansk in Poland to Kherson in Ukraine. This proposed that the route would go through the river systems of Vistula, Western Bug, Pina, Pripyat, and Dnipro. Several parts of planned route would need to be strained, dammed, dredged, or drained. The section of the E40 waterway running from the Kiev reservoir to the Black Sea would require regular dredging work. With our research, we want to show the existing picture of the content of natural and technogenic radionuclides in the several rivers, including the Dnieper River. So, the aim of our researches was a determination of specific radioactivity and distribution of natural and man-made radionuclides in modern sediments of the rivers flowing into the Dnieper-Bug Estuary. The data obtained in this study may serve as the baseline data of radionuclide concentration in modern sediments of the research rivers and water reservoirs. We have carried out large-scale investigation of modern sediments, lower reaches of the Dnieper and the Southern Bug, as well as their lower tributaries, the Ingulets and the Ingul rivers, respectively. The sediments of the Dnieper-Bug Estuary and two reservoirs have also been studied: Korchunovsky Reservoir on the Ingulets River and Sofievsky Reservoir on the Ingul River. The sampling points were located along profiles that crossed the investigated objects. The Dnieper River research area was the lower reaches, below the Kakhovka hydroelectric station. The research area of the Southern Bug was from 143 km above the delta, below the town of Voznesensk, and to its falling into the Dnieper-Bug Estuary. Samples of sediments from the Dnieper-Bug Estuary were selected along its perimeter in the section of the coast and the Kinbur Peninsula with the Kinbur Spit. Overall, analyzed 2,062 samples of sediments. The determination of granulometric composition of sediments was carried out on the basis of standard technique by sieve method. After sieving with the laundering, there were allocated 12 fractions, which in the process of analyzing the data were divided into 4 fractions: phthalate, phthemite, silts, and pelitic. The specific activity of natural and artificial gamma emitters was determined by means of a gamma-ray spectroscopy system. Spectroscopy measurements were carried out in the geometry of a Marinelli container with a volume of 1 decimeter cube, which provided the maximum sensitivity of the analysis. The total beta activity of sediment samples was determined using a special device. The granulometric composition of sediments in the rivers of investigated areas is determined mainly by their hydrological regime. In the select examples of the Tetiana River, sediments are dominated by the pelitic fraction. More than 50% of sediments have particle size less than 0.05 of a millimeter. The Dnieper River undergoes to siltation to a lesser degree than the Tetiana, but a common trend to get silty is traced. Now you can see granulometric composition of the Dnieper River sediments. In the Ingul River, left tributaries of the Tetiana, the share of large fractions naturally decreases from the top to the mouth, and accordingly the share of fine fraction increases. In the Ingulets River, right tributary of the Dnieper River and the right part of the picture, a similar pattern is violated in the district of Privary City, where there is a large mining and metallurgical complex. The research water reservoirs, Sopivsky and Karachanovsky, nowadays are lake-typed watercourses. The concentration of the pelitic fraction into them is 74 and 77% respectively. The granulometric composition of the Dnieper-Bug Estuary sediments is heterogeneous. Samples taken along the Kinburn Peninsula and the Kinburn Spit are represented by homogeneous, well-sorted quartz sand, which does not contain clay impurities and is 98% consists of psammites. Samples from the section of coast are represented by different particle size classes. I would like to emphasize that the granulometric composition of sediments is directly related to their ability to absorb various pollutants, including radionuclides. Thus, despite their tendency to silting in general, natural spatial distribution of sediments has preserved into researched object. Exception are areas within a body of large industrial cities. The result of our investigations of the specific activity of natural and artificial gamma emitters are presented in the next figures. The mobility and bioavailability of radionuclides in the aquatic environment are regulated by their chemical forms and site-specific environmental characteristics. The latter determine rates of leaching, fixation, remobilization, as well as sorption-desorption of the mobile fraction, its solid-liquid distribution. In general, the data about natural radioactive elements in the sediments of rivers flowing into the Dnieper-Bug Estuary demonstrates moderate specific activity, which, however, clearly correlates with the granulometric composition of sediments. The presented data show that the higher specific activity of natural radionuclides and radiocesium-2 among researched objects are registered in the reservoirs. The low specific activity of natural radionuclides were registered in the Dnieper River. Radiocesium of Chernobyl origin, determined by us, is contained in the sediments of all studied water bodies. The places of its greatest concentration coincide with the stagnant areas of reservoirs, in which the sediments is represented mainly by the pelitic fraction. The data for long-term transformation of chemical forms of radionuclides in sediment in the long term indicates the existence of a remobilization process, that is, the result of fixation. After deposition of radiocesium, the fraction of its exchangeable form does not decrease to zero, as should happen during irreversible fixation in theory. Radiocesium decreases to a certain level, independent of the amount of radionuclide applied, and then does not change significantly because of an equilibrium steady state between fixated and remobilized fractions. To sum up, The result of our research shows the specific radioactivity values and distribution of natural and man-made radionuclides in modern sediments of the rivers flowing into the Dnieper-Bug Estuary. The data obtained in this research can serve as baseline data in neutral radionuclides concentration in sediments of rivers flowing into the Dnieper-Bug Estuary. The obtained data can also be used for further monitoring of the specific activity of man-made radionuclides, in particular radioactive. The presence of natural radioactive elements in river sediments is due to geological, hydrological, and chemical factors, whereas radioactive has Chernobyl origin. For implementing plans to construct the section of the E40 waterway from the Kiev reservoir to the Black Sea, regular dredging work will be required. This can lead to resuspension of sediments and secondary water pollution. Taking into account the presence along the forthcoming waterway on the Dnieper River, so specific radioactive objects are the bottom traps for Chernobyl origin radionuclides and imperfect radionuclide storages near the town Kamensk. So such research is necessary. Thank you for your attention.